Exam 2 on Wednesday will cover what chapters? A lot is not the answer. A lot, that's for the final exam. That's a lot. 6.6 till 8.2. Good job. That's what you need to know. 6.6 to 8.2. Thus, we're starting with improper integrals, then areas, rotations, volumes, work, and then sequences and series. Because you have homework due tonight, let me again, if you missed the class on Friday, one more time I will mention the difference between sequences and series. Series. Is it better? Okay, I'm getting better. Someone told me cheese, series. Oh, series. But faster. It's getting better slowly. I decided to fix the problem of how I'm saying series. Series. So, sequences versus series. Sounds so weird. That is 8.1, 8.2. We only know two things. The divergence test and geometric stuff. So let me show you. That is going to be 12% or 18% of the exam. Usually 2 multiple choice questions. Example. If you have a sub n, which are 3 over 4 to the n. Example 1 of the multiple choice question, and you saw it on the practice exam, can be, if you see braces, that's a sequence. 3 over 4 to the n. That's a sequence. Diverge, so converges. We're not going to ask anything else. No expansion, no shrinking, no partial sums. Literally just one question. The behavior of it. Converges versus diverges. If you see a sum, bless you, then that's a series. Like so. Now, you start the same way. Look at that. You don't even have to remember anything here new. Start with the limit. No matter geometric, non-geometric, you just start with the limit as n goes to infinity. Check the tails of a sequence and series. For the what's the answer? 0, right? Because the denominator goes to infinity, 3 over infinity gives you 0. It's like way to memorize it. Dividing by the huge numbers gives you small numbers. For the sequence, that's the answer. Boom, done. So don't overthink. For the sequence, we wanted to see what's happening with the data point. And the data point shrinks to 0. So we say converge to 0. Converges to 0. If the answer is 5, converges to 5. If the answer is infinity, diverges. With the series, that's not enough. We just did divergence test. Divergence test. We only know 2 things. Divergence test checks the tails. The tails must go to 0 in order not to blow up as a sum. It does go to 0, but that is not sufficient enough condition for this answer to be convergent series. So it's mandatory condition, but it's not enough. Thus, not enough info. I will be doing this kind of thing quite a while in the next couple of weeks. Not enough info. Use another test. Use another test. And we're going to start learning more tests on Friday after the exam. I was supposed to teach you a test, divergence, convergence test before the exam, but I don't like doing it before the exam. It's new material before the exam. It's just mean to do it to students. So I always try to reschedule the way that we take the test and then move to the next material. I hated it. As a student, I hated it. I'm trying to prepare for the exam, and then there's like a new stuff happening, and they expect me to concentrate. So use another test. We don't know any other tests yet. We're going to learn them on Friday. So for the exam 2, you only have one way to get out of this problem. Geometric series. Sounds so weird. Geometric series. Okay, so let's do that. Geometric series has a shape A. R to the n minus 1. N is from 1 to infinity. And it equals to a capital sum. Let's call capital S. First term 1 minus R. If And only if, I of f means if and only if. You don't have to memorize that. You will see it a lot in math in the future, if and only if. Their condition on R is less than 1 by absolute value, exactly. So, converges to S. If, actually, like so. Converges to S if R is less than 1 by absolute value. A is the first term. Well, for this example, we have sum 3 is outside, 1 over 4 to the n. That's how I rewrote the original problem. Whatever is in parentheses, that's your R. R is 1/4. That's not important. What's important is that's less than 1 by absolute value. Then we know that the series will converge to capital S, and we just need to calculate that. A, 1 minus R. First term over 1 minus common ratio. Everything depends on what first term is. First term is not necessarily 3. So that's why I decided to show this nice example. Let me just make up some number. Give me a number. 8. What if it's from 8 to infinity? Now the first term is not 3 anymore. So be careful with that. I actually have to calculate the first term. So it's going to be, let me calculate first, I guess. A equals 3 times 1/4 to the 8. That's your 8. It's the first term standing by itself, like so. And it's some kind of number. It's 3 over 4 to the 8. First term of the geometric series. Now, put this in the box if you want. So that's the formula you need to know. Answer converges as geometric series to capital S, which is a sum. That's why it's a capital S. Then A is 3 over 4 to the 8. And then it's 1 minus 1/4. And you can simplify that somehow. It's 4 minus 1 over 4 is 3 over 4. So it's 4 over 3. 3 cancel out. Oh, it's actually not a bad number. 3 over 4 to the 8 times 3 over 4, 4 over 3 cancels out. So it becomes 1 over 4 to the 7, I think. Oh, that's the finite answer. Those are 2 problems, very beautiful 2 problems for the test. Multiple choice, A, B, C, D, E. A converges to 0, B converges to 1, C converges to 1 over 4 to the 7, D diverges, E none of the above, right? And then for sequence, the same thing. Sequence converges to 0, converges to 3/4, converges to 3, diverges, none of the above. Can you do that? 6 points each, so that's already 12 points. Total 12% of the exam 2. Maybe even more if there's 3 problems. Because maybe I want to have 1 problem that blows up. Then I would add 1 more, probably with a divergent answer. That's the difference. Sequence versus series. Sequence just gives you the answer right away, so it's too simple. And we're never going to deal with sequence after that. Until you go to data science, you might have it there. After this, we just work with series. That's it. Questions? I go fast on purpose because that's not a new material. Remember, my exam reviews have a goal. If you don't know something, you put like a star and you like review. You don't get desperate. You know that you need to review it today and tomorrow. If you okay, you like, okay, it's fine. If it's so-so, maybe put some note to review. If you don't know anything, you need to learn it by Wednesday. Yeah?
Just to make sure, I'm trying to find the first term again.
The first term, oh yeah, thank you for asking. The first term, plug first n, whatever n is. So we had plug. In your homework, n was 0, 1, and I just made randomly 8. Yeah. Did it answer your question?
Yeah.
So I plugged it in, and that's the first term. Thank you. Yeah. See, good. Very good notes now. Thank you for asking. Now let's go to the very beginning. So I'm done with reviewing chapter 8. That's it. That's what you need to know for the exam too. But your homework is due tonight. The faster you finish your homework, the more time you have to prepare for the exams, because you have many, I'm pretty sure. But 6.6 was long time ago, improper integrals. Do you know the definition of improper integrals? Improper integrals. Those are integrals that are not proper. Duh. What a genius answer. Improper integrals have some kind of discontinuity. They don't give you a finite answer as a number. It involves limits. So something off is happening. We had three cases. Case from like A infinity or minus infinity B, those guys. If there's infinity, it's obviously improper. Some kind of infinite behavior is happening. Example 2 was from A to B, but say B was a point of discontinuity, or A was a point of discontinuity. So there was a whole or a vertical asymptote there, like division by 0. And 3, integral looked nice, and that's what, it's funny that for whole calculus 1, we did not give you any bad integral up until now. We faked it all. But actually, there's so many integrals where there's a discontinuity at C, which is between A and B. So it's hidden there. Then you break it. Then you break it into from A to C and C to B. Sometimes it doesn't work, but we never covered those cases in this class, so you don't have to be bothered. And solve each using method 1. So that's what we have. We learned this, so you expect 1 or 2 improper integrals. That's 12% of the exam, again. And I like to review this example. Let's see if you remember. Also, this chapter reviews how to integrate, use substitution, trigonometric functions, and stuff like that. From 0 to infinity, 7 over 4 plus x squared dx. I see infinite sign. This integral is improper. It means it's never going to give me a finite number, even if it gives me 7. It's not a finite number. It approaches there. So it's not a finite area. To deal with it, we treat it with a limit. Now we pretend that the integral is proper from 0 to b or t. Choose any letter you like. Let me do t for a chance. 7 over 4 plus x squared dx, and t goes to infinity. At the very end, we're going to integrate first, find the answer. And at the very end, we remember that t actually is a variable, and it goes to infinity. Good? Let's do that. So I kind of keep writing limit for a while without using it. See, so scary. I think many people sneezing. My throat also hurts today. Like, I hope not to get sick. That will be a disaster to get sick for the test. It's always scary. And also allergies. And it's a combination. What is the integral of 7 over 4 plus x squared? Boom, boom, boom. Some kind of tangent, arctangent thing? Yeah, arctangent. What kind of arctangent? Something use substitution should be involved, blah, blah, blah. So, and what happens with 7? Gets out, exactly. So it's 7 integral from 0 to t, 1 over 1 plus x squared. That would be perfect, because arctangent gives you 1 over 1 plus input squared. So to deal with that, I'm factoring out 4 from the denominator. So it becomes x over 2 squared. That is not very important. I mean, it's a use substitution thing. You just need to be careful doing that. Dx. Then limit. So this chapter requires you to remember or figure out how to deal with integrals. So it goes back to 6.1, 6.2, 6.3. 7 is outside. I can even kick it out outside of the limit if I want to. It's going to be arctangent or tangent minus 1, arctangent of x over 2, not over 4, because it's squared, input squared. And there's a quarter outside. It's some algebra just happened. It's from your homework. It's a quarter or 4. I think it's correct, right? Two squared. I think it's 2, right? They factor out, yeah.
Wouldn't it be 7 into 2?
Yeah, I think it's 2, right?
I think so.
Yeah, I was thinking about 2. Why? Can you explain?
Oh, because we could just use 12 squared instead of like 12 can be written as 2 squared, right?
Exactly. That's what I'm thinking about. And like, no, I think it should be 2. It's 2. Oh, that's too fat. Let's do 2, 2, because this one is 2 squared. 2. Yeah. Well, that one was correct. We don't have to do anything here. 2. 7 over 2. Because we're factoring out. We're using 2 squared inside. Like so. Bar from 0 to t. So if you stuck with this algebra, put a note, review. That's what this review is for. So at home, review what the heck did it just happen. Equals. Still don't do limit. I still need to have a finite answer. So plug the t. 7 over 2. I would kick it out, but it's fine. Arctangent t over 2 minus 7 over 2. I would kick it out, but it doesn't matter. 0. Equals. Now let's deal with t later. What is arctangent of 0? To answer the question about what is tangent minus 1 of 0? That means answering the question of tangent of what angle gives me 0. That's how you reverse it. It's called inverse function for a reason. You can inverse it. Tangent of what gives you 0? 0. In other cases, but it's restricted. Domain is restricted, so we only choose the one in the domain, which is 0. Everything depends on this variable now. Arctangent of infinity over 2, that's arctangent of infinity. The question is now, what is arctangent of infinity? It's exactly the same logic. Arctangent of infinity, what is that? To answer it, you ask yourself, tangent of what angle gives you infinity?
Infinity.
No. Pi over 2. And that's how do you know? Because of either graph, maybe you remember the graph, of not of arctangent. Most people don't require students to remember inverse functions. You know the original one, and then you know how it was reversed using the line as a mirror. Arctangent is a chair. I like saying it because it's true. Look at that. It's a chair. You can sit in it. And it's restricted between minus pi over 2 and pi over 2. And let's keep repeating forever. Like so. But for the inverse to exist, we only need 1. For the inverse functions, we're restricting the domain. So it's from minus pi over 2 to pi over 2. Tangent goes up to plus infinity and beyond. That is not true. It's to beyond and infinity, actually. All mathematicians like to say this phrase. And down to minus infinity. Minus infinity at minus pi plus infinity plus pi. So example can be from minus infinity to 0, and the answer will be negative pi over 2. Thus, tangent of what angle gives me plus infinity? Pi over 2. Does that make sense? Pi over 2 and something is missing. 7 over 2. Good job. I was wondering if anyone noticed. Pi over 2, but it's also 7 over 2. So it's 7 pi over 4. Integral does not equal 7 pi over 4, but it converges to it. It converges, let me write down the phrase. Answer. Converges. It's convergent. It is a convergent integral because it's converging. At infinity, it converges to, see, I used all the 3 terms. 7 pi over 4, like so. Can you do that in the test and any other cases like that? And I'm talking about these guys. I have them in the review. 2e to the minus x at 0 and infinity blows up or behaves nicely. You can skip Laplace transform. Minus infinity and 0. Another arctangent, but minus pi over 2. Some log, minus infinity and 0. How about log? What does it do? Minus infinity to infinity, that's too much work. But practice, it's good practice. And then these guys, from 2 to 3, and then we divide by 3 minus x. So division by 0 is happening. Have to figure out that. So practice these guys, and I just choose one of those, change the number, and Here's a nice problem for the exam. 6 points or 12 points. Yes?
We can get minus infinity to positive infinity questions, right?
Yeah. Yeah, minus infinity. Oh, I mean on a test, minus infinity plus infinity, too much work.
Okay.
So I usually just do one or another one. Now, that's good for 6.6. See? Quickly and productively. What is the hardest part of the exam too? What do you think? There's no right or wrong answer. I'm just curious. Because I know what you're going to say. But what do you think it is? What's the hardest part of the exam too? Improper integrals? Okay, well, we can just review it. So it's nice. You practice this. You should be fine. Yeah?
I think for me it'd be 7.6.
Work.
Word problems.
Many people say that. Work is the hard one. Anything else? So I think work and washers and shells. All three either confusing or lots of steps or both. Confusing and lots of steps. So let's do that. Let's start with volumes. Volumes, which is 7.2 and 7.3. I'm not skipping 7.1. 7.1 is area between graphs, and it is part of 7.2, 7.3, so I'm going to naturally review it at the same time. I'm talking about washers versus shells. What happened with disks? Disks are part of washers. Disk is a filled-in object, while washer is a ring. So it's disk with another disk inside. Disk minus disk. Solid minus empty. And shell is unfolding. Well, the most important thing in all STEM classes in school and college is to remember the formula. If you don't know the formula, that's a game over, unfortunately. So the formula V for washer is what? Pi r squared minus pi r squared. That's exactly how I teach it, because then at least you remember the shape of it. And then, of course, you need to know what the heck is going on here. It's dx or dy. Pi r squared minus pi r squared versus shell method gives you the different formula, because now we're unfolding it. So it is 2 pi r and h, and also dx or dy from A to B or C to D. Here you go. Know both formulas. That's going to be like 75% of the exam is these two chapters and work, because free response will be from these two chapters. It's not a secret. It's the most, let me write, free response question for the in-person classes. We give free response questions, and it always goes to washer or shell because it has steps to grade. One free response question is 20 points. So that is already 20% of the exam. Oh, I said 75. I think I meant 35%. So 20 questions, then it's probably 1 or 2 multiple choice. It's 6 or 12. That is like 36% already gone. That's what I meant. 36% or more of the exam is those two chapters. I don't know why I said 75. Now, remember the formulas. And now you know what is happening here. So, first of all, the idea of pi r squared minus pi r squared. Solid minus a whole. R goes from the center of rotation up or down to the outside layer or to the inside layer. And then you subtract solid minus empty. And because of how I just draw it, now I can make a very cool claim that R is both R's is area between graphs. Area between graphs. Small r and big R. It's top minus the bottom or right minus left, which I'm going to review in a second. That is not all. Pi r squared minus pi r squared. If your 3D object does not have a hole, the small r is 0. So both of them are disks. But the second disk will not exist if there is no empty part. So it makes sense. The empty radius shrinks to 0 in that case. Now, if it is dx, so let me do like so. Dx case, that is rotation, let me write down, rotation about what axis? X-axis, thank you. Why there's only one person yelling? Everyone else have no idea what's going on. I hope you do. Or anything parallel to x-axis. So y equals -4 is parallel to x-axis. Everything horizontal. dy is opposite. Y-axis. Or parallel to y-axis. How about shell method? Let's do exactly one by one. Change the color a little bit to pink. The x for shell will be which axis? Y-axis, thank you. Or parallel to y. And the the y case will be x-axis. So it reverses. Shell method was introduced for several reasons. It's creative. I see 3 reasons personally. It's creative. Instead of slicing through, we're unfolding like an onion, the 3D object, and collecting the shells, or like paper mache. Or the second reason, I think, is when I can't use x variable to integrate, and I want to use y variable, I use another method to flip the variable. And that's how you play between 2 methods. And a third reasoning, I think, is because engineering department really likes complicated problems. So they like to introduce a lot of weird applications. So you know whom to thank, especially for the 7.6. Why would mathematicians put pumping water gravitational forces in math class? The engineering department, go talk to them. And then don't tell them I complain. Yes?
Well, if it's about like a point, like x equals or y.
Yeah, so it is, it's this guy over here. It is, if it's y equals -4, draw it or imagine it, and that's parallel to x-axis or horizontal. And if it's x equals 7, for example, then it's parallel to y-axis, yeah. So remember, it's horizontal or vertical no matter what it is. That's a case with a shift, yeah. Okay, now we have formula, we understand how to use washer, we know the rotation. How about the shell method? The shell method has r and h, and those are the functions here. R matches with the variable unless there's a shift. So r usually is your x or your y unless there's a shift. H is the area between graphs. Area between graphs. That's where 7.1 comes into the picture. And obviously, if it's the x case, you need to find a and b. If it's the y case, you need to find c and d. Ta-da! That's how you do it. That's how I like to review it nicely. And now let's do the example. Example. There's a 2D object bounded by BDD, bounded by x equals square root of y, x equals to 3, y equals to 0. And then it was rotated about, and you hope there's no shift, x-axis. And let's do x-axis. X-axis. Solution. Step 1, I don't think you can do it without the picture. So either I give you the picture on a test because I'm nice, or you have to draw the picture by yourself, but then I only give you easy functions. X squared, x equals y, so something everyone's supposed to know. Parabolas, lines, cubic function, sine and cosine, that's what we assume you know. Well, I don't know how to draw x equals square root of y. That's kind of already a problem. So when x is square root of y, I understand that both x and y have to be non-negative. Y because it's inside of the square root, and x because it's a result of the square root. Now, let me multiply both sides, and I will have square both sides. Y equals x squared. I know how to draw that, but I still need to remember that both have to be non-negative. Because when you square both sides, you lose that special condition or restriction. So you have to keep in mind the domain was restricted. Y equals x squared is a nice-looking concave up parabola. But now x is negative here, so I don't like that. And I will only use this part. That is the piece of x. That's how the x equals square root of y looks like. It's one of the hands of the parabola. X equals to 3. whatever, somewhere here, x equals to 3, y equals to 0. Here it is. Y equals to 0 is a floor. And we got the area. It's restricted. Here you go. That's already costs points. If you could figure out that, here you go, you got points. Now, step 2 is to figure out the rotation. Rotation is happening about x-axis. So I'm going to make a note to myself. Here's the rotation. If rotation is happening about x-axis, x-axis rotation, then it is dx case for washer, but dy case for shell. See, I already can do both. Well, I can now think which one should I do. Either I tell you use shell and then you do shell, or you choose by yourself. Sometimes it's obvious that you have to do one or another one, but this one can be done both ways. So let me then do it. 3. Use washer first. Use washer first. And then we're going to do shell and compare. That's what the quiz was. Quiz 6, you did one problem with 2 methods. Let's do washer first. If it is washer, I will create a 3D picture, here it is, and stare at it. I'm looking at it, and I try to imagine, can I put some water in it? If I can, it has a hollow part. If I cannot, it's solid. But at least now I know it is a dx case. From here, I immediately can write down the formula. Washer dx case has a formula. It is pi r squared minus pi r squared dx from A to B. And now I'm looking at it and I don't see a hollow piece. What does that mean? Huh? It's a disk, so small r is 0. No empty part inside of the object, inside of the 3D object. That is only identifiable through the graph, I think, visually. What do you think? But as you can see, I just remember one formula, pi r squared minus pi r squared, and then I follow from there. So you need to know the formula, obviously. Now, continue. Since it's the integral in terms of x, I need a and b. A is 0, b is 3. What's the convenient case? 0 and 3. I would kick out pi outside, but it's fine. Pi r squared dx. Small r is 0. We don't care. Now, I will do the capital R. Capital R and small r are area between graphs. Areas. Well, let's just do area. So, because it's a dx case, it will be top minus the bottom case. Top minus the bottom. And now I have to review this part. 7.1, and I will continue the example. 7.1, areas between graphs or curves, whatever you prefer. We had 2 cases. The x case was top minus the bottom inside of the integral, like so. Actually, then I don't have to do that. Just integral top minus the bottom from A to B. And then integral from C to D was right minus left. Right minus left. If that is confusing for you, then remember it's bigger minus smaller. But for x-axis, we have from A to B. So then whatever is higher is bigger. And scanning goes from my head to the floor. But for y-axis, we go from C to D. Then my measurement will be from right to left, from bigger to smaller. Kind of the idea. Or like what's the size of the building? A roof to the floor, right, is east to west. Took me a second. East to west. That's a scanning. And in calculus 3, we take 7.1 into 3D, and it will be front to back. It's always bigger minus smaller. So 7.1 is one of the most important chapters in this class, but somehow it's not so very kind of seriously used. 7.2, 7.3, we will ditch them forever after this class. We'll never go back to shell and washer methods and whatever, but 7.1 actually is important. You will see in Calculus 3, super fun. But again, introduced by the engineers. So we're gonna use this knowledge and finally finish the problem. Radius of this object. Find the center of rotation. I found it. Shoot the laser up or down towards the function you draw. I'm shooting and hit the outside part of it. So laser cuts through. That is capital R. And you see how I draw it? Capital R is the area between graphs. Between two graphs. Top and the bottom. And that's how I put the equations into the integral. Top function is y equals x squared or x equals square root of y. How do you know? What? Yeah, but I mean, we have both versions. Y equals x squared or x equals this guy. Why? Well, the graph is the same thing. No, look at this. It's the same equation. See, it's the same thing. It's because you know the integral is in terms of x, exactly. It's the x case. Because of the dx case, I already fixed everything from there. X equals to 0, x equals to 3, and guess what? Y equals something in terms of x, and y equals something in terms of x. So y equals x squared, and what's the other function?
0.
Thank you. Y equals x squared, y equals to 0. It's a floor. And then if there was a hollow piece, remember, you repeat the process. Small r, shoot, hit into the gap, and you repeat the process. It's also top minus the bottom for the small r, if there's any. In this case, it's 0 minus 0. That's why it exists. It's just 0. I think that's the hardest part, is when you create it, then integration is fine. But this part, how do you feel about that? Can you do it? That's, I'm telling you, that's going to be 35 or more % of the exam. So one problem, or one chapter, I guess, can fail the whole exam. They really want to, in this class, to make sure you understand this topic. And it's also more expensive in the class because it goes to final exam. I can already tell you. We always put one washer, one shell in the final exam. So if you learn it once, you already got lots of points. Put a huge fat star if you don't understand this. This is must do. Out of anything in the class, you must learn this for the exam. Pi, I would kick it out outside. Integral from 0 to 3. X squared squared. Don't forget to do pi r squared minus pi r squared. Everything inside of these parentheses is just big R. So R have to be squared. R. And then it's going to be x to the 4 pi x to the 5 over 5 bar 0 to 3. And the answer is 3 to the 5 over 5 pi units cube. That's a washer method. Does that make sense? Let's try to do shell method. This example can be done in both ways. 2. Now let's try shell method. Should be the same result. But because it's rotation, because we have a rotation about x-axis, the answer will be, the integral will be dy. So I already know the formula. Volume is 2 pi r h dy. And everything is in terms of y. So it's going to be x equals r and x equals h. But y equals c and y equals d. Everything should be in terms of y inside of the integral. So the moment you know the method and you know the case of it, formula follows from there. So you should understand 3 steps. Choose the method, or it's given. Understand the case, the x dy, and then formula shows up. Equals. I would kick out 2 pi outside, but you don't have to. Now, c and d. Now it in terms of y. And this is when I don't recommend to have a 3D picture. Because, as you can see, many people might think that it goes from minus to plus. But that's not true. For the shell method, C and D or A and B are coming from the 2D picture. So from 0 to whatever that intersection is. Do you know what this point is? I don't know. You just plug, you solve the intersection. X equals square root of y and x equals to 3. So y is the other way. 3 squared, right? 9. Plug 3 into x, square both sides. Y is coming from 0 to 9. From 0 to 9. So make a note maybe. 2D picture. Don't use 3D to mess up picture. To mess up the limits of integration. R matches with the variable. So this notation now is bad. If there's no shift, R matches with the variable. So can you fix what I wrote? I think it will be confusing. X, that's what I wanted to say. X equals R of y. X equals h of y. Or else it looks like x equals h. It doesn't. It's a function. That was my point. So in this case, it's y. Radius matches with a variable unless it's shifted. Rotation is not shifted here. So we're lucky. H is the area between graphs. But which one is it? Top minus the bottom or right minus left? Because of the dy case, we know it's right minus left. So it's going to be right minus left. Now I need to figure out what the heck we're talking about. Let me go back. What is the height of this object? The height of this object is not this. Because it's lying down, it's going to be this. It's a water bottle that lies down on the floor. So right minus left will be now this line, which is what? X equals 3 minus the parabola. Let me write it down. X equals to 3, and then do I put y equals x squared again? No. And that's how you know there should be no x there. X equals and should be function in terms of y. Everything should be in terms of y until we reach calculus 3. Then we'll have x, y, z, t, phi, alpha, and everything at the same time, to be honest. And theta. Don't forget theta. So that is the hardest part, as you can see. 2 pi y3 minus square root of y dy from 0 to 9. Just building this integral already costs you 6 points in the multiple choice or 20 points for the free response, or both. Then it's 26 points. 2 pi integral 3y minus y to the 1/2 plus 1 3/2 from 0 to 9 dy equals, let me see how much time left. 10 minutes, good. 5 minutes. Blah, blah, blah. Should be the same number. I wanted to check, but I want to talk about work a little bit. 3 to the 5 pi. 3 to the 5 over 5 pi. Should be. You can double check if it's true or not. Can you do these two methods? What if each of them is a free response? That's 40% of the exam. Imagine that. And one more multiple choice, then it's 46. 46 of the exam might be just these two chapters. And it involves area between graphs, so you also need to review that. Only two things left. Arc length, just a formula. That was 7.4. Arc length. L is integral from a to b, a giant square root, 1 plus derivative squared. And it's either the x case or the y case. Just remember that, know how to use it. And now the work problems, 7.6, work. I don't put springs on the test, so ditch the springs. I only do pumping water stuff. Pumping water. Pumping, yes?
Is there going to be like a hemisphere problem like that was on?
So maybe, so let me tell you right now, yeah, the questions are what the shape of it and blah, blah, blah. Remember, I will show you this classical one and go from there. What if we have this shape of a pool, like so, and it's from 0 to 10. What kind of 0 is that? From 0 to 10, but the water is only reaching the level 8. And now there's lots of things happening here. What is the radius? Okay, they give you radius, say 7. And then they say pump just all the water out. All water out. No fountain this time. All the water out. How do you proceed? You imagining that you're slicing. It's a horizontal slicing through this water. And now you have those horizontal slices of water. Here it is. And you're lifting them all. So the formula is, do you remember? Volume is, there's two constants, rho and g. I give you that. Integral. And then you have what? Area of the object. And then the shift, right? And then dy. Because we're going up, they like to use y cases, but actually it doesn't matter. Everything, it should be correct, whatever is in parentheses and limits of integration. There's a numerous way of doing these problems, as you noticed. That's the confusing part. I only stick to one way on my tests, so it makes it more very straightforward to students. Just one way, very consistent. And this is how I explain it. A and B are domain for the water. Y have to belong to something to be in a domain. So Y tells me, oh, water exists from this level to this level. So what is Y? From 0 to 8. That's how I remember it. Yes, there are many other versions of it. You can shift it a little bit, blah, blah, blah. You can subtract the gap if you want. So, but I just clearly understand. If Y is at the end of the integral, that shows me the domain of Y variable as a mathematician. So like, okay, it's from 0 to 8 then. Yes?
So on the test, we're only pumping water at the bottom, not at the top, on the sides, or anywhere crazy?
No, we're doing from here like so. Yeah? Yeah, classical way, yeah.
What's the symbol to the left of the G mean?
Density.
Oh, this one, rho.
Ah.
What was it? Density of the liquid. Yeah, thank you. That's how I draw rho. That's actually the correct way. Rho. I think sometimes it's like that. RHO. Oh yeah, that's welcome to physics. We're like how come they're not consistent with that? But G is gravity. I like that. It's easy to remember. Yes.
Will we only be pumping water out of the cylinder?
That's a good question. No. So let me continue the problem in 5 minutes. We figure out 0 to 8. Now the parentheses matter. What is in parentheses? It's a shift. And instead of shift, I'm calling it a lift. How far do I lift the liquid? Lift is happening. If there's no fountain, it goes to the top of the container. So it's 10 minus y. Does that make sense? So you can interchange those things with u substitution, blah, blah, blah. So that it can be y. But on the test, I like to stick to exactly one way. This is the classical way. If there's a fountain, which I can draw right now, if they have exactly the same problem, but there's a little fountain involved, and this fountain is at the level 15, the container is 10, the water is still 8, like so, then it's going to be what? Integral 15 minus y. And it is still from 0 to 8, because as I mentioned, I can see it's a domain for the water. But each slice is being lifted from 0 to 15. So y goes up with a shift. So that's a shift, but I see there's a lift up. There's a rho and g. And now the only thing is, what is happening with A? A is the area of that slice. If it's a circle, like in this case, that's pi r squared, right? Pi r squared, and I gave you r. If it's a square, then you know that too, it's r squared. I don't give you triangles on the exam. So usually it's circles and spheres and squares, rectangles. Something you can do fast. And the pumping, either with fountain or no fountain, no triangles, no Hooke's law. This is how I remember it consistently. If you check my practice exam, you see it there. The practice exam, right? You saw it. So take the practice exam as often as you can. It's optional. but the more you do it, the better. Please come early on Wednesday. Work hard, don't forget homework, don't get sick.